38, it says, which is a counterexample for the biconditional and angle measures 80 degrees if and only if the angle is acute. All we need to do is find an acute angle that's not 80 degrees, because if and only if means it works both ways. So the converse would be, if an angle is acute, then it is 80 degrees, and that is not always true. So in this case, we would mark A, since 60 degrees is acute, but not 80 degrees. So the biconditional is equivalent to the spelling phrase I before E except after C. At least for me, this one was kind of tricky to think about, but it helps when I wrote down what's actually happening here. So if it's I before E except after C, so if we have a C, then it's always E, then I. So I before E except after C, so you switch it. And so this one actually ends up being G. So E comes before I, if and only if E follows C. So for 40, which conditional statement can be used to write a true biconditional? So it's the original statement and its converse are true. So if a number is divisible by 4, then it is even. So the converse would be, if a number is even, then it is divisible by 4. And that's definitely not true. Like 6 is an example. Next one is, if a ratio compares two quantities measured in different units, the ratio is a rate. Okay, so let's say that's true. How the converse? So a ratio is a rate if it compares two quantities measured in different units. Well, that is definitely true. Just to double check, let's take a look at the last two. So if two angles are supplementary, then they are adjacent. Well, that's not true. The supplementary angles just need to add up to 180 degrees. They do not need to be adjacent. And if an angle is right, then it is not acute. Well, that's true. Right angles are not acute. But then the converse is, if it is not acute, then it is a right angle, and that is definitely not right. Okay, last one is to suppose A, B, C, and D are coplanar, and A, B, and C are not collinear, not a straight line. What is the truth value of this biconditional form from the true conditional? So here I drew angle ABC, and I'm really looking at, well, I know that this statement is true. So if the measure of ABD plus measure of DBC equals this whole thing, then D has to be on the inside of that angle. But for a biconditional statement to be true, the converse of this original has to be true. So if D is in the interior of this angle, then this statement must be true. So that's what I did here. Drew angle ABC, picked any point on the interior, and made that point D. And then we can see that angle ABD plus angle DBC would equal ABC.